Hi there, what I'd like to talk today to you about in this video clip is the following: metal structures, alloys and some carbon structures. Let's start with metals. If I look inside a metal, what does it look like? It consists of metal ions, there they are, metal ions, and plus charge, plus, and in between those ions you've got electrons. These electrons are free electrons that are allowed to move, and these are called delocalized electrons. That's why metals conduct two things: electricity and heat, because they've got free electrons that can carry the energy in the form of heat and electrons. However, metals, pure metals, they could be not that strong, they're reactive, they're etc. 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 So how do we modify the physical properties of a metal? The answer is mix it with another metal, and these are called alloys, such as, you got brass and bronze, the mixture of metals. Even that gold ring I've got on there, it's not pure gold, it's a mixture of metals. So how do alloys work? Well, how do they affect the physical properties? For example, if I took gold, it's very reactive, it's extremely soft. How do you make it less reactive? How do you toughen it up? The answer is alloy it with other metals. I've said that word metal. However, if you took something like steel, it's an alloy of iron and carbon. Let's look inside a typical metal. Layers, and these are joined in not one dimension or two dimension, joined in three. It's like a solid box. There they are, like that. And there's the plus ions, plus, and in between it, electrons. And I subject that to a bit of force. What happens is that layer can move that way. And if I subject its force going down, that layer can move that way. However, what happens if I put larger atoms in that and smaller ones in there? It disrupts the movement. And suppose I made that one there, I took it out and I put a larger one in there like that. That is larger than that, and then I put another atom in there. They disrupt the deformation. The layers can't fly. So adding another metal would make it less ductile, make it less prone to oxidation, makes it, in lots of cases, stronger. Let's look at gold. Gold, when it's pure, is 24 karat gold. Then you get, is it 18 or 18 karat gold? Then you get 9 karat gold. What is the difference? This is pure gold, impure gold, impure gold. And if I add things like nickel and silver, Ag by the way, and copper, it changes the properties of the gold. Gold becomes less reactive, it becomes stronger, it becomes more durable, it's tougher. So that's why they alloy metals with other metals to form alloys. Did I just say alloying? Well, it's true. You can often have 5 or 6 metals, and in the case of iron and steel, you know, they add chromium, makes it stainless, vanadium makes it extremely hard. Let's now look at carbon structures. Carbon forms millions and millions of compounds because they have single, double and triple bonds. However, I want to look at pure carbon just by itself. In the previous video clips, I said that carbon comes in 3 main types: diamond, graphite and amorphous carbon. If I took diamond, the carbon atoms are joined in 3-dimensional structures. That's a tetrahedral structure, a tetrahedron, which meant that that tetrahedron is joined to another one, joined to another one, joined to another one, joined to other tetrahedron structures in 3 dimensions. That is why carbon is in the form of diamond is extremely hard. Another form of carbon is graphite, which comes in the form of hexagonal carbon atoms, C, 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 and that is what graphite looks like. It's carbon joined in hexagonal rings in 3 dimensions. However, when you look at its structure in greater detail, when I said in the 3 dimension, it's a solid and it consists of layers. These are hexagonal rings. That's a graphite ring, graphite ring, graphite ring, graphite ring, and in between it, those layers, you've got delocalized electrons. These delocalized electrons are free to move, so that's why graphite, unlike diamond, is a conductor of electricity. In recent years, the scientists, they've developed more carbon-based structures, and these are the graphenes and the fullerenes. Graphene, by the way, is just one thin layer of carbon atoms joined in 3 dimensions, i.e. it's a single layer of graphite, a monoatomic thickness, 1 atom thick, and they are used in lubricants, nanotechnology, but we're speaking about that in the next video clip, and fullerenes. Hello, I almost couldn't spit it out then. Fullerenes are when carbon atoms are joined in different structures, and these new structures are like balls, like a soccer, a football, in which, you know, you get the shapes of them. They could be in rings of 5 carbon atoms, 6 carbon atoms, 7 carbon atoms, and they're these hollow structures consisting of the carbons joined in rings. And then you get the concept of a nanotube. Nano, by the way, I'll explain that in the next video clip, means extremely small, but what happens is, in the case of a nanotube, a fullerene again, it's like there's a tube and this is like rings of carbons made up in structures. Again, they could be rings of 5, 6, 7 carbons, that hollow structures. It's like there's that pen and there's a ring of carbons joined in these 5, 6 and 7 ringed structures. What can you use these for, these fullerenes? Well, they're extremely strong, they conduct electricity, you can get them in extremely thin layers, and they're used in things like tennis rackets. You know, you're subjecting it constantly to, you know, whack, 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 whack. It makes them extremely strong in both tension, in compression, etc. And reinforcements. And the fact I said these are extremely small, they're used as lubricants. I'll quickly explain what a lubricant is. If you get surface A and surface B and they rub past each other, it wears them out and they get hot frictional heat, and eventually the moving parts will break down. And if you imagine this, you put a very thin layer of something that cuts down that friction, you prolong their life, they're more reliable. Anyway, I'll be speaking more about that in the next video clip, in which I'll speak about nanotechnology, which is based on small things.